For problem number 2, the power regression that is located on Desmos. Before we get to this problem, I do have it, I think, on here. Yeah, I do need to go over with you a couple of things. First of all, the square root function, you guys should know that the square root function looks like this. You should also know that instead of using radical notation, you can rewrite the square root function using exponential notation. So the power of that x right there is a 1, and the index on that radical is a 2. So we can rewrite this as a power x raised to the power of 1 over the root 2. Power on top, root on bottom. And you can see that those are the same function by me turning them on and off. They're the exact same function. And of course, you can rewrite it instead of writing it as a fraction. You can write it as a decimal, because 1/2 rewritten as a decimal is 0.5. So green on top of the blue on top of the red. They're all the same function. You need to know this because when we do the power regression, the result is going to come out in the form of a decimal, but you should be okay with taking that decimal output and rewriting as a fraction or writing it in radical form. You are expected to be okay with that. Now, I do need to show you one more thing because this is kind of weird. The cube root function. Here is what the cube root function looks like, and you should be aware of what that, because that's a parent function that you should have memorized, so you know that's what the cube root function looks like. Very similar to the square root function, we take the power off that x. That x has an exponent of 1. The index on the radical is a 3, so we can rewrite that as x to the 1/3. And so you can see black graph is same as the purple graph. So those are the same function. Now, when you go down here, you change 1/3 to a decimal, and I'm going to do it for you right here. 1 divided by 3. It comes out as 0.3 repeating. Now, Desmos understands the difference between a repeating 3 and this rounded off 3. So if you go here and you type in just 0.3, when Desmos graphs that, it does not give you the same thing as the 1/3 graph. It gives you something quite different. That's because it matters how many 3s. So if you go up here and just put some more 3s, I'm going to turn this off so you can see. If you put some more 3s, it's changing it a smidge. Uh-oh, I don't know what it did. It's changing it a smidge, but you have to put several 3s before it understands that it's a repeating 3. You see how many 3s I had to put for the rest of that graph to pop up? Now Desmos understands that you mean for that to be a repeating 3, and it doesn't matter now. You don't have to put any more 3s. You don't put enough 3s, and it doesn't understand that that's raised to the 1/3, and it only gives you a graph of x raised to the 0.33333. Stopping. But if you put a few more 3s, then it understands that you mean the 3s to be repeating. So, just FYI, if you plan on graphing with the decimal. I wouldn't. I would always graph with a fraction, and that way you don't have to worry about it. So now when you are to determine if this is a square root function or a cube root function, you simply put this data on a Desmos table, and then you do a power regression. This is the regression command. Y'all know about the y1 wavy line and using the x1. The power regression is a times x raised to some power. We call it power b. So we know down here that the leading coefficient is 0.62 and the exponent is a repeating 3. So you should recognize that that is the cube root function. You can test it by typing in y equals, put in your value of a, 0.62. I'm just going to round off and then put x, and I'm going to raise it to, I'm going to do the 1/3 power, And you can see that that red graph right here went right on top of the black graph. Okay, so that came out to be a cube root is the best fit. How would we know if it was, how did I know it was a cube root? Because the exponent right here came out to be 1/3. If the exponent came out to be a 0.5, then the best fit would have been a square root. So if this table had been had been the results of this table, then this 0.5 right here would have told us that that is a best fit as a square root function rather than a cube root. So that should help you now go back and do problem number 2.